All right, so we're going to start off with the skeletal system. We have 206 bones, but when we're born, we have over 300 because they fuse to make our 206 bones. Now we're going to look at the elements of the skeletal system. It's not just our bones, but also different types of connective tissue like cartilage and ligaments. We have two different skeletons, if you think about it. We have our axial skeleton, which goes down the middle of our axis. It's going to be our skull, our spine, and our rib cage. And then we have our appendicular skeleton, which is our appendixes, right? Our appendages, our appendages, which is going to be our hips and our legs. Ultimately, our arms and legs. These two skeletons together, right, support our weight and protect our internal organs. If you look at it, what organ's in there? Brain, that's protecting, right? The organs that are inside of our rib cage are our lung and heart. And then also within our pelvic cavity, we have our reproductive organs like our uterus and other important organs for the reproduction of offspring. Now, along with bones, we have cartilage. You'll see that there is cartilage that connects the ends of our ribs, which is bone, to our sternum. We have cartilage in between our vertebrae. We think those are the discs that we refer to. We also have a little bit of cartilage in between our pubic bones, and we have articular cartilage that is on the edges of the bones that rub up against other bones within our joints. And this cartilage protects us, specifically in highly movable joints, from bones rubbing up against bones, causing osteoarthritis. As we get older, the more that this cartilage rubs away, the more we have bone-to-bone contact, and that's when we have what's called osteo, which refers to bones. Arthritis, arth refers to joint, osteo refers to bones, itis, which refers to inflammation. So inflammation of the joints due to the rubbing of our bones, right? That's what osteoarthritis is. What is a joint? Well, a joint is where we have two bones meet. Now, some joints allow for lots of movement, some allow for little movements, and some allow for no movement. And so we'll look at the different types of joints. Okay, we have different types of joints in the next slide. Now, what we don't see is actually in our skull. If you look at our skull, right, we have these like things called sutures. Okay, that's actually a joint where two of our, I'm looking at the top of my skull down. That would be like an immovable joint. But if we look at these other types of joints, like the joints in our wrists and ankles, those are called plane joints because they kind of slide on each other as specific planes. Your elbow and your knee is a hinge joint because it works kind of like the hinge in a door. This is your humerus right here, your arm bone, and then this is your radius and ulna. They pivot and swivel like if you were to put your foot on the ground and twist it. This is the most movement. Most range of movement is a ball and socket. This would be like your arm and your hip, right? Where your arm attaches to your shoulder. Saddle joint, this is your thumb. It's very unique because only the thumb has a saddle joint. And then in your knuckles, we have these unique things called condyloid joints based on the shape of one bone and the shape of another, how it fits in. Ligaments. Now, this is not a ligament because it connects a muscle to a bone, right? Now, a ligament is in here. A ligament, this is your ACL, anterior cruciate ligament. It is connecting the femur, this bone, to the tibia, this bone. This is bone to bone. So if you look at your ankle, right, okay, you have the fibula. This is the fibula right here, the outside, and it's being connected to the calcaneus or the heel bone by a ligament. Okay, bone to bone. When you roll your ankles, you typically stretch these out and they become really swollen and inflamed. That's what happens when you sprain an ankle. Bones are alive. They literally have cells that produce products that can be excreted out that actually make the hard part of the bone. Now, inside of our bones is where we make red blood cells, and we'll talk about that. That's called our bone marrow. But the outside, the hard part, is actually composed of two different types of bone. Compact bone, which is this part. See, it's really, really dense. That part's the compact bone. And then spongy bone, which is going to be this part right here. So spongy bone, which is not as compact, right, is where you'll find a lot of our bone marrow. And there's two different types of bone marrow. Oops. Okay, we have red bone marrow, which produces our blood cells. And then kind of in throughout here, a lot of the times we have what's called yellow marrow, which is just pretty much fat storage. Think of like fat as being a yellowish color. And if you notice the spongy bone, guys, it's kind of porous, has holes. It's not as thick as the compact bone. It allows our bones to be strong, yet light, because it's not so solid. Now, what we know about our bones when we're born is that it's mainly cartilage when we're born. And then it churns to bone in a process called calcification, where we add calcium to our bone. It becomes ossified. Okay? And so over time, our bones get longer and they go and churn into the hard part that you see today. You can see, here's the fetus, guys. See that curvature I told you guys about? Shaped like a C? All this stuff right in here is all cartilage. It hasn't become hardened yet as into bone. So this process is called calcification. There are two types of bone cells. Okay? Ones that build bone and ones that break it down. Osteo refers to bone. Blasts. Now you think of blast as like breaking things down, but actually think of the blast, the B in blasts, building. Osteoblasts build bone, and osteoclasts, guess what they do? Yeah, they break it down. This is build. I think of C as like, think of bone crushing and bone building. They don't really crush the bone, but they shave off the bone. Oops. They shave it apart and release calcium into the blood. Okay? So those are the two cells. You think of like putting mud on a wall to build up a wall and then shaving that mud off, right? To make that wall thinner. That's what those cells do. Calcium is the ion that is deposited into our bones. We have our strongest bones when we're 18 to 30. This is a normal, healthy bone if we're looking at the spongy bone. Look what happens to grandma's spongy bone as she gets older. Now, grandpa happens to him too, but for ladies, for you, it happens a lot quicker because of the hormone changes through menstruation. And so you lose a lot of the calcification. So if this is really, if this is less dense, when you fall, there's a greater chance of breaking these bones. Okay, so you definitely don't want this to happen. So make sure you're eating lots of calcium and having a healthy diet. There's also medication that can prevent this from happening as well. Muscular